Alright, we recognize this as a quadratic equation because the highest power is 2. So, and that's why they're telling us a not equal to 0, because if a were 0, then the highest power would be a 1, and that would be linear. So, yay. And then we recognize this as part of the quadratic formula, because remember, any quadratic equation can be solved with the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is describing the roots of the equation. Sorry about the trash. Sorry. This is describing the roots of the equation, where the function would equal 0. So this b squared minus 4ac part is important because it's going to tell you what kind of roots you're going to have. If that part were negative, you can't take the square root of a negative number. That would be imaginary. But they're telling us that b squared minus 4ac is positive, so you'll have negative b plus or minus the square root of some positive number, so you'll have two real answers. One, negative b plus whatever that is over 2a, and negative b minus whatever that is over 2a. So your answer is that they're going to be exactly 2 real roots for part C. It's a quadratic equation, so it's going to have 2 roots. They may be repeated, they may be imaginary, but it's going to have 2 of them. If it were to the 3rd degree, it would have 3 roots. To the 4th degree, 4 roots. And that's kind of what our fundamental theorem of algebra says. So just a review of the discriminants. I think I have this in another video. Sorry. B squared minus 4ac. If it's positive, you have 2 real roots. If it's 0, you have 1 real root. Because if this were 0, you'd be adding or subtracting 0, which doesn't change anything. So you just have that 1 root, negative b over 2a. And if it's negative, you can't take the square root of a negative number, so you have no real roots. And that's that.